Sir, we'll start, sir. Sir, we'll start.
1 minute, sir. I think
Okay.
sound people are there. I think we can start, sir. Huh?
Okay, sir.
Sir, Logan, sir,
Good
ready?
evening to all. Yes, sir. I'm ready. So, good evening to all. Welcome to third day continuous professional development program on digital food and agribusiness during Jan 23rd to 3rd of February 2023. And today topic is analytics for business model transmission of agribusiness organization, sponsored by the Atal Academy, ICT New Delhi, organized by the Indian Institute of Plantation Management, Bengaluru. And I would like call upon our Sangavi student representative. Can you please brief about profile of our resource person?
Sir, thank you so much,
Sangavi?
sir. Thank you so much, sir.
Thank you.
Good evening, everyone present here. It is my proud privilege to introduce our guest of the day, Dr. Lohitaksha Maniraj Mayer. He is an assistant professor at Indian Institute of Technology, Hyderabad. Prior to joining IIT Hyderabad, Dr. was a research fellow in the Business and Management Research Institute at University of Bedfordshire, United Kingdom. He was a research associate in the Department of Automatic Control and Systems Engineering, the University of Bedfordshire, prior joining to University of Bradfordshire. He received his PhD in 2019 from Department of Industrial and System Engineering from Indian Institute of Technology, Kharagpur. He has applied supervised and unsupervised machine learning, evolutionary optimization, and multi-criteria techniques for solving problems from wide range of applications such as aerospace manufacturing, online fashion markets, and food supply chains. He has significantly focused on the developing mathematical models to support cost-effective and sustainable resilient transportation decisions. He has published in leading international journals of logistics and supply chain management area, such as Transportation Research Part E, International Journal of Production Research, and International Journal of Production Economics. He is serving as a reviewer to several journals such as IEE Systems, Man and Cybernetics, Computers and Industrial Engineering, Computers and Operational Research, and several other journals of international repute. Over to you, sir. It is really great having you here.
Now session hand over to you, sir, please.
Thank you, sir. Thank you very much, Dr. Gopal, for the humble introduction and opportunity. I would like to briefly introduce myself. In addition to I'm working as assistant professor and a broad area of research. My experiences since my basically transportation modeling for food grains, and I will share one from this, and working with several other sectors. Fresh food supply chain. So a very huge project, pan-European project before joining IIT Hyderabad, University of, when I was in doing my postdoc in University of Bedfordshire. So it was a project with fresh food quality monitoring, and we will discuss some case studies from that. So I've been using different types of analytical tools, both to arrive at solutions in context of these or food in general food supply. So I would like to I hope my screen.
Yeah, we can see the slide. Sir, my side voice is a little bit low. Whether the same problem for other people? Can you confirm whether the voice is audible to everyone?
Sir,
Yes, sir.
yeah, we couldn't hear.
Huh?
We couldn't hear properly, sir.
Okay, sir. Okay, sir, please.
Some sound
Voice
issues,
is
sir.
breaking, sir.
Some
Audible, sir.
Okay, let me just check.
Now it's fine, sir. Yeah.
It is
It's
fine.
not clear. Voice is not clear.
Okay, just a
Breaking also.
hello.
Yes, sir. Yeah. Can you speak, sir, now?
Hello.
I am speaking now. Is my voice now?
But still there is a break in the voice, sir.
Let me just see. Hello.
Yes, sir.
How is it now, sir?
Yeah, somewhat better, sir. What about other people? Can you confirm? Can you increase the sound, sir? This one. Yeah. Some.
Now it is okay, sir. You can start.
Okay.
Sir, that can you increase the sound also. There is some speaker option is there. Can you check that one more time, sir? Yeah. That second one. Now try, sir.
Hello.
Yeah, it's fine, sir. Now I think.
Is it fine? Okay. Okay. But maybe that will give a better bandwidth.
Okay, fine, sir.
Is this up?
No, we're not able to hear you, sir, properly.
I think there is an issue.
Signal problem, I don't know, but.
Okay.
What about other people? Can you hear his voice? Sir voice? Jolibas, sir, is it okay? I'm not able to hear anything.
Right now, I think he is not speaking, I guess, sir.
Okay.
Yes, sir. It is not audible, sir.
Okay.
Yeah,
Your voice is not clear. Your voice is not clear, sir.
once again get back to you in 2 minutes. Yeah.
Yeah, I think, sir. Resource person, and there is a weak signal, I guess.
Yeah, we'll wait for 2 more minutes.
Hello, is it okay now? I have just changed the location.
Yes, now fine, sir. Absolutely fine, sir. Now.
Okay, I think network was the issue. I've changed the location now. Again, there's an issue. So yeah, I would like to start now.
Yes, sir.
Yeah. So today's session. Thank you very much again for the kind introduction to everyone. I will directly jump into the topic. It is analytics for business model transformation for agri-business organizations. We would like to in the context of analytics, whatever I have conducted, my previous experience This will be helpful. We'd like to start with what is the these days and transformation is taking place in general and in food supply chains in particular. And what are the different dimensions of digital transformation in agriculture, and what could be what we call as some of the practical projects. And one of the practical projects which I was involved was Reamit project, as I was mentioning earlier also, that this I was involved in pan-European project in my period before joining IIT Hyderabad. So I would like to share this experience. This project was concept executed, and also share. And finally, current research is doing. These would be the contents of.
Sir, voice is breaking, sir. We can hear your voice, but in between its break is there.
I think
Sound is fine, sir, but the some break I can hear.
okay.
What about Sangavi? Other people, Emmanuel, are facing same kind of sound, or I don't know. My internet is problem.
No, sir, there is like a problem from
Same
the whole.
problem, sir.
Okay.
So that even though if there is a break, people can follow.
Okay.
Yeah. So I would like to start off with this supply chain. So supply chain transformation, ideally, I would not repeat industrial transformation. So industrial transformation ideally took place 2.0, 3.0, 4.0. So in supply chain, similar to this, also we can say there is an evolution of the food supply chain. So majorly dealt with flow of products. Majorly dealt with flow of money.
Still the issue persists, sir. We couldn't be able to hear you properly, sir. Sorry for the interruption.
We will try to change the network connection, see whether it works.
Yes, sir. Please, sir.
Different alternatives I can try to. Hello, how's it now? Connection and connecting through the mobile internet. Hello, sir.
Yes, sir. Hello.
Speed test. I'll get back.
Okay.
It came from my laptop.
Okay.
And see whether it works.
Now it's okay, sir. Can you talk sometime, sir?
Hello. Yeah. I mean, I've been talking since last 1 or 2 minutes. Is it okay now?
Now it's okay, I think, sir. For me, it's okay. But
I mean, when I share my screen,
you check it, sir. A little bit is fine, better now. But
I'll just send the presentation over to you. If someone can coordinate to just move the slides.
yes, sir. Yes, sir. You can share,
See.
sir. Our coordinator will take care. You will share it in the chat window, sir.
Okay, sure.
Yeah. Sangha, we can share it.
Yes, sir, I'll do that.
Okay. Are you sharing in mail or chat, sir?
I'm trying to share it in the chat.
Okay.
So I just share
Yes, sir.
in the chat box.
Okay. We're not able to see, sir. I don't. Did you share directly with Sankavi or?
It's received in chat box.
Sir, I'm downloading it. Give me a minute, sir. It will be displayed.
Okay.
We can go to the supply. Yeah. So, and maybe it could be because of the presentation and it's not compatible with my network anyway. It's majorly focused on flow of products, focused on flow of information, flow of knowledge, and supply chain 3.0. In addition, been incorporated basic a desktop. It was not integrated with all the other entities, and therefore that was with the help of Internet of Things, which is the difference. Just the what we call as the 4.0. So 4.0 traditionally comes from this context. Implementation of systems in a network, not only internally, partners, responsive and faster execution issues. As things was leveraged, cyber physical system. It has evolved into a concept, and this. So therefore, supply chain inclusion of Internet of Things in 4.0. Similarly, there is sector is lower. And like if we refer to a food sector, it's a concept of things that accordingly. So things dealt with incorporating IoT devices across the different players of the food supply chain, right from the raw material supplier to the final end consumer, including the consumer or the customer. These devices, the players made the data with the required amount of security, with the required amount of transparency. In the supply chain context, same can also be applied for, can be taken in the food supply chain context. Move to the next slide. So let's just have, so when I majorly be focusing on the digital transformation aspect, called for transformation. For the implementation of digital architecture, digital supply chain, there is a lot of transformation that might be needed. Related to that, we'll be discussing. Right, so that if you can go back to the previous slide, yeah. So traditional customer, of course, if you have any other entities in between, like a retailer or someone, it forms part of the sequence. But with the advent of industry, what we call as IoT, etc., this digital supply chain coming into picture, which ensures flexibility. Transparent is one player with respect to other player with respect to the information. Communication. So digital communication or the traditional supply chain conservative and not collaboration possible. And of course, flexibility, the different variety of products, customer complaints and other issues. So there are basically what is digital supply chain? Some of the students, people who are working in this area, what exactly is a digital supply chain? Involved in the supply chain? No, because supply chain means supplying a digital product or a physical product. But digital supply chain focuses the way in which this is integrated. Right. So the same thing also applies for food supply chain. So the transport of or the movement of food from the farm to fork, if you want to say, the still the same, but the way in which the movement is captured, movement is tracked, depends upon how the digital supply chain is. So that is the Sangvi. Yeah. So this digital the authors has given this different dimensions of digital transformation in terms of product flow needs to be transformed, the change, more number of players in the market, like fresh or additional models. The whole organization may have to transform in the way in which they conduct their business. Digital operations, digital talent and skill, and culture all become critical aspects of the digital transformed food supply chain. Forward, if you can move to the next slide. So the key dimensions of digital supply chain, to be more elaborate, can be taken broadly in three categories. One is external, one is mixed. So what are the different key to the mixed means it is to the organization as well as stake. Internal means internal aspects of it. Each of these can be elaborated in a deeper way in the next slide. Able to see the use of natural resources and how optimally can we use this finally achieve economic, environmental, and social objectives in the agricultural domain, right? So financial incentives from the government for implementation of digital infrastructure. So one of the, we can say, digital transformation is there are a lot of farmers not economically well placed, other NGOs, etc., to help farmers create the awareness among themselves, provide them with the initial grant, move towards digital transformation. Something that that external dimensions, security, data sharing. So I mean, there is a lot of hacking that is happening. Digital things COVID era, and hackers leveraging this, creating a lot of problems to people who are using digital infrastructure. So this needs to be stronger data. Okay, I'm not yet done with the slide. Yeah, thank you. So next is by the government. So all of this can be achieved by external factors, external bodies, governments. Mixed, say, involving in a project where academic institutions and industries a single platform and try to build an ecosystem or execute a kind of project in order to support this. And internal dimensions may involve changing people within the organization, how convenient we can make people to use digital transformation, new technology, say or any other new technology trained to the employees of the organization, and also their opinion should be taken care of, or priority should be given to their opinion before implementation of these. Employees should be taken care of, skilled and trained to improve the particular technology. Of course, sometimes technology. So how much level of digital technology we want to diffuse into an organization? Accordingly, we must train the employees, and that is the Sangvi. Yeah, thank you. So talking about which, there is lot of right. So this is of example have been used in agri food. So tractors with sensors in order to attract or collect crop conditions, farmers, mapping of weeds, weather watchers. Okay. There are a lot of weather watchers in the UK where sense the weather data, social media data to predict marketing trends and consumer sentiments, foods, and place where one can leverage the data from the consumers and then improve the type of product offerings, any online e-business market, right? So this is this IoT can be used to improve the agri-food business sector. And there are several success stories. One can also, for example, based on the information coming from the sense field and also inside the say very we can say fertile is able to predict that the field is very fertile based on historical information. Maybe insurance rate can be provided to the farmers based on the fertility level, a particular insurance to the farmers, and based on his own farming experience, a plan can be provided to the farmers. So this to even bring in insurance models, which is a win-win for both the. So this refer to and maybe implement in our own context as well. Forward, these are just examples in agri-food. Next slide. Can we move to the next slide? So these are some sustainability implications as organization. It is revealed that 1.3 billion tons of food and 40% of food in America is by never gets eaten. So that's the data we have from food, and there is a lot of statistics we have from savethefood.com, which is a website fresh food and its waste. Next slide. Yeah, so these are some videos, and in the interest of time, we can skip these slides. Presentation can be shared with all, and you can refer to these videos showing the importance of how much food is wasted and its environmental impacts. There is a lot of sustainability implications when we focus on reducing technologies to reduce food waste. When we talk about this technologies, primarily for business analytics, so applied for food businesses. There are different types of analytics that can be added. So one is the other one is predictive analytics, and both of them can be in an end-to-end system. Calling it an end-to-end system, implementation of an end-to-end system, it means that from data to final result, connecting data to the final what we call alert mechanism or the final result of the analysis, finally to the different stakeholders. End to end, it connects right from the raw data to the final stakeholder, right? So there are in building, and second one is the edge tier, and third one is the enterprise tier. So edge tier is a collection of data. So we can install different types of sensors. It could be IoT sensors or any electronic sensors. Edge tier. So therefore we call it, I mean, it is basically interacting, right? So therefore it's called as the edge tire. We move slowly from the edge page. In the edge tire to the gateway, there is an intermediate point where all the data is collected into the gateway, right? In some access, it is very common that places, like one of the key examples is, but anyway, we have found out a solution to this. Access to slowly and transported is being stored device, limited storage. The vehicle reaches a city, access architecture is all comes under the edge tag. Each aspect, all the issues related to data collection. So once the data is, then comes the platform tier. So you can have different types of platforms. Somebody are comfortable with working with Java, somebody are comfortable working with Python, somebody with working with MATLAB. This is, but in the most advanced sense, say if you are using blockchain technology, right, to deal with the data or to build the platform. If you are dealing with other deep learning AI, with proactive models, predictive models, different types of the platform comes into all the technologies that are used. For example, technology to process, so the in the edge tire again is very raw and needs to be pre-processed. We are using for compatible with the platform or the language we are using for software or the analytics part, right? For the prediction. Data compatibility or the software compatibility is a key critical challenging issue that comes into the platform tier. One must ensure being transferred from one platform to another platform is compatible, right? Otherwise, there will be errors while transferring the data from one software to another software. All these errors must be minimized. These are the key to platform time. Also, the type of server one may use. So, services. Capacity with the cloud service. And Google Cloud services, which are available after a free trial period. They offer the huge price services. Alternatively, platforms into the physical server, which might be managing the again. I have to build all the programs, all the softwares. Buying any services server, and all the software needs to be built by the project manager or the team. So accordingly, we design the platform tier. So normally, the edge tier are called data engineers. Do this, and people who are involved in the platform tier are called we can say data scientists. And between data engineer and a data scientist, that it is incompatible with the data scientist, the project will not go forward. So there's a two-way kind of information flow between this. And also the third tier is the enterprise tier. So in the enterprise, we do the same thing, edge tier, the same thing across different functions of the organization. The customer relationship department, if you have a for example, a procurement department, if you have a supply chain management department, so all the data and analytics related to all the departments, enterprise tier. It is just different departments integrating it into one big software. One of the best examples, right? So, but ERP software generally only gives the information. It's very software that we can also send alerts to certain it is going waste. This enterprise tier can communicate information to the corresponding department or the corresponding supply chain. What is going waste now? This you instead it is going to reach somebody else. Mechanisms will all be communicated from the enterprise tier. Infrastructure, we can say the architecture, end-to-end system. When we talk about a full end-to-end digital system implementation. Thank you. Just which was one of the very interesting projects during my period of postdoc in UK. So REMIT stands for Improving Resource Efficiency of Agribusiness Waste throughout. But this is a project which was academic partners, business development partners. So in the previous slides, I was briefly discussing about the mixed, what we call in the different dimensions, digital transformation. They're all different organizations. Here, funding. So European Regional Development Fund, which is part of the European Union funding. So here, and all the different parties involved, stakeholders involved, were also co-funding in order to support. So there were industries funding support as well to this contribution from industry institutions, also the academic institution in the co-funding aspect. Everybody came together and was trying to basically address different scenarios of this food supply and come with some University of Bedfordshire there, and University College Dublin, University of Nantes in France. Companies, Livstone is a company, Weiser is a company, and it's an academic institution. Everybody were involved in their own kind of roles and responsibilities in order to contribute to the project. And there were some business development organizations which industries and promote activities which we conducted as part of the project. So thanks. Challenge or the goal, I can say, a certain reduction. So the data indicated 143 billion euros of food was wasted every year. 5% of food waste occurred in agri supply chain. Previously it was EU 28. Now somewhere in between Brexit happened, so it is now EU 27, and UK is out of EU 28. So this project was there even before Brexit. With the Brexit, that's a different issue. Focuses fresh food. So 4 types of vegetable food was focused: fruits, vegetables, fish. All of these different types of fresh. Number of IoT sensors of Agri sub target and deploy IoT sensors, resource supply chain of food to collect data in the cloud and conduct big data analytics to identify sources and patterns of food waste with a view of tackling them. So we can move to the next slide. So with this challenge, the project aimed to reduce metric tons of food waste, equivalent of 3 billion euros per year. So this was the goal, and to avoid 5.5 metric tons of year of CO2 emissions. This was the reduction, the food waste reduction in the. If we save around 1.8 metric tons of, would avoid 5.5 metric tons of carbon dioxide emissions, contributing to sustainability. Next slide. So we aim to meet these challenges and achieve the objectives by by deploying IoT sensors, improving resource efficiency, with some example of how we intend to achieve that. So food being transported in the truck would be subject to some kind of analysis. So there are different technologies that the project was trying to investigate, which I will discuss in the case study part. So based on the technology, whether the food is going waste, and then transfer the data to a central server, whether the food is going waste or whether still remain in a particular condition and in a consumable condition. All this data would be analyzed in the center, finally sent to all the stakeholders. Decision would be taken, and stakeholders supposed to be rerouted, or if the food is or if the food is right. So, right, can you move to the next slide? Would actually be transported for trains. If should also be processed, whatever food that is processed would be finally, intended to be transported. So which was called as the intended customer. The technologies that it is going to go waste, or we can say food that is going to go waste will be transported to alternative destination. It's depicted in the next. So it is shown here. So data is collected from the food in process data platform, and if it is going waste, then it will be sent to the consumer. So this was the broad picture of the implementation of the project. Is what we will see in the next. Yeah, this is the remit approach. To just be more specific, we can see the data. food quality can be predicted with the help of temperature data, with the help of humidity data, with the help of carbon dioxide emissions, atmospheric pressure, illuminance, and organic compound data. So there were sensors all of this data, and these sensors were planned to be installed either in stationary, depending upon the type of environment, different types of these sensors. And there were some, one of them was Raman spectroscopy fluorescence. I see examples of technologies in India also. So I think startup or something from IT Madras to build a particular type of kind of a handheld spectrometer to measure and then predict the quality of the food when it is loading or unloading from a truck or from the warehouse or the storage location. And so these were some things here also in this project in terms of this influence technologies. From all of these, big data analysis to send. This one important thing that needs to be taken is we try to target food at risk. And if a particular food is said to go, says that will be sent to alternative destinations, food charities, like I was mentioning earlier. You can move to the next slide. So you can to actually go through this on the, you can just briefly see project was trying to do, right? So if you can click on the first link, it's which can you click on the first link? If I hope the voice will be audible to everybody. It's taking its own time. Wait, I guess. Is it playing? Sangvi, is it playing browser? Hello.
Again, there is a problem in the audio.
Okay.
Browser.
Okay, no issues. Then I think you can move forward if there is an issue. Normally, if you click and then move to the browser, you should see the video. But if it's not happening, then we can move forward. Okay. Yeah, you can refer to the videos at leisure later on. That was part of the Remit project, which focused on and into the details of the technical aspects, because spectroscopy, to highlight here things being researched, people were trying to develop here to measure food quality. Spectroscopy basically, which was very huge, laboratory kind of to measure food quality on chicken samples. They were taking chicken samples, okay, and we're trying to arrive at a particular wavelength which determine the quality of the food, right? So if you place the food sample below the spectrometer, a wavelength spectrum or a Raman spectrum, and based on this spectrum, the intensity of would be taken out from this particular spectrum, and then that intensity would have a particular, or that spectrum would have a particular wavelength rather, and that particular wavelength would actually be mapped with food sample, and then the idea was to come with the wavelength that corresponded to bad quality food, right? So, and then finally, for a given type of food, if this is the wavelength of bad quality food, we can use that information to predict bad quality food in real time, right? So that was the idea, and there were first it was too difficult to get the wavelength of the bad quality food. The way in which the data Raman spectroscopy is not what we call a kind of a time series, because if you have time series data, you have time tag along with each data point. But with Raman spectroscopy data, you have with just 1,000 types of spectral images. So how do you manage with that is, and finally arrive at the bad quality wavelength was the computational challenge. Second, this was very huge. They had a of small size, not in such a transported or easily transported or made mobile enough in order to keep it in a truck. Let us know the or to get the value of the quality of the food in a movable truck or something. So that was a key challenge. They were trying to technology. Spectrometer can be put inside a truck and finally give the data when the truck is moving, right? And not in the laboratory environment. Challenge they were trying to address, and the case study that was being done as part of the project. Please. So once they get the data, see, as you can see this figure over here, a small light figure is the equipment, Raman spectroscopy equipment. So that needs to be put inside the truck, or they're trying to investigate options, send the data from the truck to the lab. But anyway, food sample will be truck itself. So there was a trade-off that they had to make, either put the equipment inside the truck or take the data from the truck and sample out the food from the truck and then take it to the lab. The second option to the project, because the project was to get real-time data. So they were trying to investigate, try to put the equipment inside the truck, collect the data, and then maybe the analysis, the food spoilage would be done in a center. And then the information would be sent out to the truck driver or the stakeholders involved with the food sample in this truck. So project, and you can see how this possibilities that can happen if the food is being detected as either sent to the alternative, it will be sent safely. If it is not going to go waste, right? So that was the idea of the project. And to implement this, again, they wanted to investigate. If you move to the next slide. So I say the project partner, after the University of Nantes was working on this, France, and they have suggested two solutions: data management architecture. You can have a built-in database. Solution A, you can have a built-in database which can help us make the analysis inside the truck itself. And finally, the result can be directly sent to the drivers or others. Earlier, second option was you can collect the data and then send it to the cloud. And the cloud will take care of the analysis part. Finally, do the analysis and send the data to all the stakeholders. Based on the convenience to the equipment, they will probably have suggested solution. So taken care of, the analytics part was taken care of by other different partners. So labs were involved in the installation part of the sensor, trying to capture the data and send it to the cloud. And once the data is received onto the cloud, it will be stored in a physical server, which was being taken care of with University of Bedfordshire. And so I was involved in developing the inside the physical server. And finally, the data that was being stored inside the physical server will be sent to all the data analytics partners, different data analytics partners, such as we were also involved in part of the data analytics, University of Bedfordshire and other institutes, IT Trally and Stenex was a private organization which was involved in data analytics part. Yeah, so this was the whole loop, and that was with respect to the previous slide was with respect to the use case of using Raman spectroscopy, right? And this use case, which you are able to see on the screen, is a pilot test again mid processing. Just challenges. One is to detect Clostridium esters. So Clostridium esters, which will form on the meat, properly handled, maybe because of some kind of environmental issues, Clostridium esters will form, and then it is very hard to detect the early formation of these Clostridium esters. You realize, I mean, the industry was, they are realizing the problem of this. Meat samples have to be taken out and discarded. So the present method they were following was some pesticide or some chemical was being sprayed on these buds of these Clostridium esters in a periodic manner. So whenever they do the spray, they have to shut it and processing. So the challenge is Clostridium esters people were unable to do. Second challenge is processing line, because of which their productivity was lower because of this problem. So this used by early detection was possible with the help of sensors. Was of sensors. They predicted that their productivity and profits would increase. So that was the first problem that they were facing. the meat processing plant was facing weight loss of food. Generally would be hanged in something known as chamber, right? So they would have where the meat needs to arrive at a certain level of by the drying process, in which its quality is. So if it loses a lot of good quality, if it doesn't lose moisture, then it is also not of a good quality. So the correct level of moisture content inside the meat should be maintained in such a way that customers. They were doing it in a thumb rule. They installed exhaust fans at one corner of the room, as you can see over here, and based on experience, moving the hanged meat out of the room based on certain kind of thumb rule experience. Scientific exact happening once it is deposited at a particular section. The exhaust fans may happen greater near to the exhaust fans. It may happen slower with respect to at the farther point away from the exhaust fan. An equilibrium or equal kind of distribution or scientific way of inside the chamber in such a way that weight loss happens consistently. And these two pilot tests were being conducted with this processing and sensors. So the sensors to measure the weight loss here, but also humidity. In such a way that they are not spoiled humidity, right? So once a particular type of sensor, because the humidity inside the chamber, obviously moisture, and there was a spoilage in the sensor. Which and a specific type of membrane that does not allow humidity to affect readings that come out of the sensor. Procured and installed in order to get the accurate temperature reading. So there were these were the challenges that came with this particular two pilot tests. So this case study. Can you move to the next slide?
Sir, sorry for the interruption, sir. Actually, we were supposed to have a break at 7:50 for 10 minutes. Can we have that break now? As participants are requesting for the break.
Go ahead with the break. Sorry, I was continuing. Thank you for reminding that. We can have a break and maybe catch up again at 8:30.
Yes, sir. Sure, sir. Thank you so much, sir.
Hello. Can we?
Hello, sir. Hello, sir. I had a doubt, sir. Sir, in this fresh food delivery, like how will be the placement of the sensors? Will it be for every crate or for the entire truck, sir, to collect the data?
Which is that each business should decide for itself.
Okay.
If it is a truck that is taking that is having maybe only one type of food transport,
Okay.
then we install just one sensor.
Okay.
It's like dealing with multiple food types.
Okay.
It is better to transport these food types which are having kind of behavior or spoilage behavior,
Okay.
right?
Alright.
So you can categorize certain ranges of some temperature range, some other temperature range. You can categorize the food into 3-4 groups. Sensors.
Okay.
So that's the second thing. And third thing, in some businesses, customer orders. Some customers order a different, category of a different combination of.
Okay.
In that case, there is no option but to have an aggregated kind of temperature control or management scenario.
Okay.
Right? So it would be dependent entirely on the business in sport. That is.
Sir, what if the crate is full of tomatoes only and we are able to get only the topmost food quality of the tomatoes? What about the bottom part of the crate tomatoes which is present in the crate? So how do we handle that such criteria, sir?
If then we can definitely install some sensors, but and some sensors. That is one thing. And second, we can also install. So in order to measure how much shock at each tomato, right? Shock or vibration is at a certain tomato. So not just would be predict the quality loss. Combine the data with temperature as well as some of them might be installed towards the bottom of the crate.
Okay.
Right. So, yeah. So that's the.
Sir, and what about in this second use case about that meat? So for each and every package, we need to have sensors there, sir, once again, to find out the bacteria, this one.
So the solutions that based, so they were yet to figure out sensor bacteria formation. So bacteria formation identify first in the lab using this polymerase chain reaction approach in the lab. So once they are able to identify a specific meat composition or pH level, we can say inside the meat spoilage or the Clostridium bacteria, then maybe to measure the pH level on every on the conveyor belt or somewhere where the meat is flowing in on the conveyor belt, and accordingly one can maybe try to gauge the.
So it's a mixture or a combination of different criteria, parameters to handle the food spoilage, this one, sir.
So it entirely depends upon for this bacteria. So based on the laboratory experiment, if they are able to find out a certain combination, humidity combination, and pH level, so these combination of result in a certain combination of to get hold of the quality level of the closely of the meat sample. Based on that, they will install on the conveyor belt at that part of the conveyor belt where meat is flowing, right?
Okay.
So, yeah.
Okay, thank you, sir. Got it.
So if Sangvi can share the presentation once again, we can maybe proceed for the next topics.
Yes, sir. Give me a minute, sir. I'll check.
Okay. Am I audible now? Hope my voice is audible.
Yes, sir.
So this was one of the other cases in the Remit project. Here it is relevant to one of the questions raised by Ms. Veena here. So it was about a trying to similar to we can call Amazon or Big Basket. Smaller scale, it was trying to convert the offline orders to online ordering and fulfillment kind of business. So we're collecting all the orders in a fulfillment center, accumulating the orders and then assembling and sending it through something known as e-trucks. The different orders from the fulfillment center to an intermediate hub, and from that intermediate hub, it used to destination. And the way in which the trucks were, the food was transported, they had different types of plates, ambient, frozen, and chilled. The foods, according to their requirement, they were placed in ambient or frozen and then transported to the respective destination. So the challenge was they wanted to replace their traditional way of working to control the temperature of each. So the way in which they were working now was they used ice packs to control the temperature. The person who was transporting this, either the driver or the driver, was what needs to be just to understand how many number of ice packs in which to monitor the temperature. So accordingly, he would place the food orders in those sections. So it was experience and the knowledge needed to be transferred from one personnel to another personnel if job. So it was a huge, not very scientific. And they wanted a scientific model to say, if this is the combination of the fruit, then this is the temperature profile that need to be maintained inside the truck. Yeah, so this was the achievement they wanted to with respect to, but they had a lot of data because sensors and data coming in from their transport, because they were already into the digital business. Try to build an AI model to predict or to arrive at a temperature profiling model, right? So that was their requirement, first requirement. Can you go to the next slide, please? Yeah, we can move the next slide as well. So this is just the their business model transform from traditional food market. So it is just depicted pictorially here. You can move to the next slide. Ms. Sangvi, can we move to the next slide? Next slide. Hello, Sangvi, can we move to the next slide? Yeah, thank you. So, simple scenario again, which is scenario followed by this. So they had a fulfillment center. Crates were being used. Two types of compartments and 36 in the order, food order, size of the order, they would place either in the 24 compartment crate or 36 compartment crate. And finally, it is taken from the fulfillment center to the intermediate hub, and from that hub, it was being transported to an end consumer. Can we go to the next slide? So the data transported to the server called as the remit.visor.com. It was a cloud server, which was initially being used on a temporary basis, conducted in a server physical storage location, finally this data being stored in the physical storage partners, as mentioned in the previous part of the lecture. The results of that analysis would be transported to would be sent. So in this, also see something known as complaints, right? So complaints, it was the second requirement that the company wanted to actually achieve. The first requirement was to develop a customized approach, and the second, map the from the to the consumer by the consumer or the customer. They may have several complaints regarding the food damage. The point raised by Ms. Veena over here just minutes ago, she was saying what happens to food, which are placed at the bottom of the crate, for example, and mapped with the customer complaints, and would be, maybe placed or rectified at a later stage, or maybe a corrective action would be taken in the in the subsequent. Mapping would be done in such a the vibration profile that would be associated with each crate and each food type that has been transported inside the crate, with the customer consumer complaints, and we would maybe doing a root cause analysis for the reasons of the damage based on the data we have from the vibration. So this is the approach that was so just one Hello. Yeah. So yeah, architecture for the data transfer from the truck to the server, analytic partners, and then finally to this data that was being I wanted to show this example to just highlight the two major requirements that the company wanted to resolve using big data, using the IoT technology, right? So first one was to get a customized for each crate. Second, to complaints with the data that is generated from the shock and vibration sensors. Vibrations team, they only wanted to understand the reason for that customer complaints and to improve their processes in the future. Shock and our team had visited their industry transport location and then installed these shock and vibrations to measure the shock profiles. So again, the challenges at this point, I mean, for this pilot was there were some challenges while installing these sensors. It's very comfortable to have the IoT devices for scan. So it was convenient to install the gateways or the IoT devices inside the driver's cabin because of easy connection to internet or open environment and these kind of things. But it is not convenient to have obvious because you use this. There could be radiations out of that, and it could be a help drivers. Although their products concern for the driver, if it is a concern for the driver, then we cannot install the sensors. Have to come out with an alternative way of installation and install the gateways, the IoT devices inside the backside of the truck itself. Is kind of a challenge, and finally it was possible, and they were able to collect shock data. So this one is second here. So explanation audible to all, or was I muted? Just wanted to understand. Can I? Previous slide was. Yeah, I had briefly explained, just summarized the requirements. Should I repeat once again?
No, sir. But just there was few breaks in between. That's it, sir. You can continue.
Yeah, I will just repeat what I mentioned here. I just mentioned that the company was interested to resolve two of its problems. One is to get the customized requirement. They wanted to map the customer complaints with the shock profiles or vibration food transport, right? So we suggested certain vibrations. We wanted to have this data to improve the processes in future. So one of the challenges I was explaining that to install these sensors, I mean, the easy way to install this IoT device was inside the driver's cabin. So IoT device majorly involves two components. One is the sensor to the center. So when we install the sensor, Sensor will be installed near the food, but the gateway will be installed somewhere on the truck, somewhere nearby. But the easiest, but the drivers were not convenient to have it installed inside the driver's cabin because of health reasons, that they were suspecting some health issues because of the radiation. But if the driver himself is not, we cannot go ahead and install it in the driver's cabin. So we had to come with an alternative way to install that sensor. And they mounted it on the driver behind the truck. So a mounting procedure was need to be designed to mount it on the truck's interior, behind of the truck's interior, and then it was possible to collect data from all the food crates and vibration data. So this was the type of scenario that we had for dealing with fresh food transport for about 4 hours, which had a span of transport. So if you see, we can see different types of cases. One, the meat case we saw earlier, is being processed. Supply chain, where the it's the issue, and it was yeah. So the there are the Raman is corresponds to supply chain happens from the producer, right? So we saw all 3 different cases where the sensors end of the supply chain. Based on the business supply chain is not possible in the case of this world. So each scenario deeper way, and then type of sensor need to be chosen based on the convenience of the business as well as the stakeholders involved. Considering the like the one example which I mentioned was the driver's example. So considering the social aspect, also we need to design choose the sensor from this. If you can move to the next slide. So present one type of so all the different models, as I was mentioning, can be majorly the AI, ML, and big data analytics and kind of models which are used to make the quality of food based on historical data, maybe the predictive models. Once the data is generated and the system is operating regularly, and a lot of data is being generated, one can also try to build prescriptive models. They are basically models which help us give solutions for large implementation of a given model, right? So here on I will just present 2 or 3 case studies of different types of prescriptive which I have worked upon and also published. This is motivated actually from the last study on the the fresh food transport scenario, right? So the Dutch pilot which we studied. So this model is also motivated from that, but it is a so here we are trying to analyze different types of technology enabled controlling vans. So you can have say for example fresh food transport in dry vans, transport in temperature control vans, monitoring capability. You can have fresh food transport with the temperature control vans which are having monitoring capability also. Designated that as K1, K2, and K3 type of vans, not having any temperature control mechanism, is having temperature control, but there's no monitoring as such. So levels of with this and IoT implementation, as it is a challenge, digital implementation. In this study, trying to see if there is a certain level of we can say certain transport that can be used also serves the purpose of reducing the food wastage. Say, for example, if you go for K3 vans, implementation with having both temperature control as well as monitoring capability, its cost of implementation is very high. So do we need this kind of vans in all cases? In which case? So can we use type of van which is coming capability but helping us, it comes at a lower cost? Under what circumstances can we use such type of vans? The dry vans where there is no temperature control as such, and in what cases do we actually do not need this digital technology and these kind of technologies to monitor food and control waste? To investigate in this particular prescriptive model. So we're considering, for the sake of simplicity, 3 types of vans here, and with food being transported from a limited number of producers, retailers. Can we move to the next slide, please? So this is the broad area, broad context, and formulation was, we built an objective function that minimizes the total cost that is involved to transport the food, which also loss of, the food quality loss cost. So there are 3 components of cost here, as you can see here. First is transport associated with route from I to J, right? And the second cost of transporting from producer I to retailer J in truck type, in the kth type of truck, right? And D was the distance that was traveled. Second, multiplied, and the aggregated cost of the whole transport was taken into the objective function. And the third component here, you can see in the equation number 1, is the cost of food quality loss. So PK is the penalty that is incurred for quality loss in case, right? So this penalty is based on, say, for example, if X amount of waste, low quality, that food product is not bought by the consumer. So the price of is considered as penalty, right? So because it is not going sold, so penalty to the business. And Z is a variable that actually captures whether the food is going waste or not. And R is a that we used, and X is the it is transport. So out of X, going waste, it is going waste or not, it is a binary variable, binary parameter, and PK is the penalty that is associated with the total loss of equation or expression, total food quality loss cost. So the total cost, including fixed transport, so the demand constraint was written by incorporating the food quality loss. Production, supply chain demand constraint, all of you must, but demand constraint is generally written that double sigma, if you are going from I to J, double sigma Xij should be greater than or equal to the demand of that destination to incorporate the food loss. So food loss Zij, right? So out of X, the food is lost. If that needs to be satisfied at node J, right? That needs to satisfy. So therefore, the total amount of quantity transported from I to J demanded node J, which is the destination. Similarly, the capacity constraint was also considered, which is can be transported only if it is available at the origin node or the producer node, right? So these and just for very simple with just one demand constraint and one availability constraint, and it is can be further modified to incorporate further level of complexities this model based on the practical scenarios. Then with this model for this model with threshold levels of penalty above which the specific was chosen. So if the penalty goes above a certain limit, then K2 becomes K3. So this was the trade-off that we tried to achieve. Can we move to the next slide, please? Yeah, so 4 theorems were proposed here. One is for this particular type of model M, show different distance ranges. We proposed distances, change in food quality. Dry vans without temperature monitoring and control is the optimal choice. Intuitively, but it was equations. Dry vans without temperature monitoring and control temperature control vans and these kind of vans to transport over a short distance. So second medium range distance. Medium range distance, it was the food freshness of with appropriate temperature control vans without monitoring capability as the optimal choice. For medium range distance ranges between DK1 to DK2 as shown in this figure here. So DK1 was from around 500 kilometers to 50 kilometers. But it was seen that K2 type of trans viable and economical. And if you can move to the theorem 3, which is the most important theorem which we have derived. Can we move to the next slide? Yeah. So we have derived the value of penalty. Right? We have derived the value of penalty above which vans shift K3, right? So, mentioned is nothing but the price. But if it means if it includes the sustainability cost, all of them, if they are considered, say that is wasted. One can imagine how to penalize is a subjective. How much cost is a subjective matter because, but others can say I am not only losing the price of the food, the amount of emissions life that has caused because of the emissions export of food that is wasted. So there could be several social, there could be social environmental cost involved. So all of this, if the penalty goes above a certain, then the K3 type of vans becomes more optimal. So if you want to include all the agenda, the government agenda, the sustainability agenda, if you want to include the social dimension agenda into the business, to ensure that we are using digital technology and IoT devices, leverage this digital technology and IoT devices to sustainable transport, to ensure transport with the addressing also being captured here basically. That means and K2. So that means using control vans capability is required and becomes more viable than the K2 type of vans. So that's the from this particular study to capture the food quality loss with respect to different technology levels inside the truck. Right. So next, so this is next. So I would like to just briefly show another work here, which is being conducted by my PhD scholar who's currently doing PhD in this particular area. So this work corresponds again fresh food transport, but in the omni-channel context. Focus on shifting traditional single channel way of working to omni-channel distribution. So before I introduce this work also received an award from one of the conferences I jointly organized by NITI Mumbai and Arun Jetni. How omni-channel can be designed and analyzed. One can make a choice as to what level of freshness must be given using a talks about the trade-offs, particular penalty value above which certain technology type of van selected over another technology type of van. We talk about what level of freshness. We define a freshness 0 to 1. What level of freshness should we maintain at 0.5? Should we maintain at 0.2? Right, so best involved to maintain high level of. So in all of this, there is terminologies that one may need to understand, that each food is associated. So purchase at any given point of time, each fruit has a certain purchase by the 20% of the time. That means 80% is transferred. 80% of that food is wasted. That's the meaning of purchase probability. And there is a associated with each food item or at a given retailer. So for apples, a customer acceptance. So the customer, I will accept this or vegetable only it has 50% life left in it, right? Or the retailer will accept the food only if it has 50%. So the transport has to be done within the 50% span of the shelf life of the food. So the shelf should happen within 5 hours and should reach the retailer within 5 hours. Quality direction points. then the transportation can be planned accordingly to reach within 5 hours. This problem was addressed in a multi-echelon kind of network where the transport was different collection, different farmers would different collection centers and distribution centers, and from different distribution centers to the retailer. So this was food supply chain. And if you can, so to decide freshness keeping effort needs to be decided at each. The next slide. So there is always a trade-off between the cost of fresh and the fresh food quality, right? So that is a trade-off that we're trying to investigate here, right? So if we invest more to control the fresh food loss, but the cost would be high. If we invest less, the quality would be lesser. Again, the cost would be lesser. Yeah. Can we move to the next slide, please? Yeah, so as I was mentioning earlier, the whole supply chain transport of fresh produce from farmers to collection centers and then to the distribution centers. There were 3 channels that the food can follow. First channel is kind of channel. In the local Telangana context, we have something right? So Manakuragailu is a retail outlet where people come buy and take the fresh food and go home. So it's a system. The other channel, Dutch case of where the orders come to the fulfillment center and it is shipped to the consumer locations. Third channel is the pickup points. Scenarios. These pickup points became very famous and popular, where people were, and instead of delivering to the, there were pickup points which were set, and people used to come to these pickup points. Used to collect from these places. Formulated the problem to capture all the different transportation of fresh food transport. So the first motor type of channel, the second deliver to home, BODH, online, and pick up at store, BOPS. It's about the modes that were happening with respect to this particular case. If you can move to the next and have a look at the have a brief look at the mathematical model. So this is the same thing, just written in a arrow diagram, flow diagram kind of thing. So further, move to the next slide. Yeah. So this is just the Manakuragailu case. Predictions kind of real-time data was taken and it was implemented and solved using the model. So we'll just variables and the assumptions of the model that we follow. If you can go back to the previous slide. Yeah. Potential locations of collection, distribution center, retail outlets, pickup points we are making here, right? So there's no He considers one distinct type of fresh produce. That is what we try to initially formulate the problem for only one type of fruit, right? Fruit produce. It depends on availability of the fresh produce. Echelons means distribution and are deterministic. And next, produces full truckload. So the model only used mode of transport, and there is no half truckload or partial truckload transports that would happen. It's assumed that the trucks are utilized. Last, transportation. So we are assuming that maximum a few hours. There is no time related issues that we are addressing in this particular study, right? So because there are no demurrage cost or huge, there is no freight transportation as such. We assume that we'll transport it in the single time period only. So the included how much quantity of fresh produce needs to be transported from say a collection center, from the distribution center to the retail outlet or e-fulfillment center points, transported based on the demand at each of these locations. Of course, flow means it is just it is a binary variable depicting whether the route from a particular collection center to a distribution center is happening. Say there are 2 distribution centers. Export happening or not? If yes, variable will be 1. Otherwise, it will be 0. That we captured here. And third is the third and most important and novel part of this variable, flow variable in most models. Is considered and trying to capture here and say whether the collection the distribution is 0. If the decision, it means that the distribution will not have to invest in freshness keeping, right? If Z is 1, it means that distribution have to invest in freshness keeping, right? So if Z is somewhere, it means that they have to invest in a certain level. So that's the important aspect that we try to capture for a certain case. Yeah, so we took a sample case and then we solved it for low and high problem instances. Values of the decision variables here that were obtained and the values of Y and Z that were obtained. Can you move to the next slide? So the key observations from this study, freshness keep penalty cost and total cost is minimum with no requirement to investment towards effort. And finally, as the penalty cost increases, towards fresh. So you can see the graph also. So this graph is increase in cost, freshness keeping effort and penalty cost was observed with increasing number of nodes. I can go through this. In the interest of time, I will request to slide. Yeah, these are some conclusions from this study, which you can also explain earlier. Can you move to the next slide?
Yes, sir. I'll move to the next slide. Sir, as we are running in short of time, I request you to end the session within next 10 or 15 minutes, sir.
Have completed the, I mean, the remit cases and cases will be done in the next. Thank you
Yes,
for the
sir.
reminder.
Yes, sir. Thank you, sir. I'll go for the next slide.
So from this study, to see the second. Can you move to the second? Next, the previous slide. One more previous. One more previous. Yeah. So with the increase in quality loss cost, freshness distribution to attain optimized total cost. So this is observed and also proved in this particular study. I mean, the increase in the to deploy freshness keeping effort, and the level keeps on increasing with the increase in the quality loss cost. Right. So that's it. And moving to the next. A lot of slides for the final case difference, but I would like to only highlight the important aspects of that last to the further slide. You can skip this one that I had referred to build this particular. So this particular work is coming is where I have tried to build a prescriptive optimization model considering social environmental considerations for the food grain supply concept. The focus more is on the transportation and the contribution that transportation of food grains would cause in addition aspect. I will directly jump into the diagram for this particular model. It was all motivated, so you can see the importance of change is just to as a motivational aspect for this study, and also some of the data that we have already seen previously, but pictorially it is shown here that how significant this carbon footprint is actually how significant it is with respect to the total carbon emissions of. If you just take the across the world, just the food carbon footprint from the food, right? So it is falling. USA, just usage across the world is falling third in place. That is given by this source, LULUCF. You can also refer to this particular data from Food and Agricultural Organization website. Okay, yeah. So moving forward to the actual work that was being done in this. Yeah, so this was the research that focused basically on capturing economic, environmental, and social aspects. Next slide. Model related aspect. This is which I have used to justify the novelty of this particular study for the purpose of. Some papers have addressed ecological, some papers have addressed the environment, the social. So therefore, that is where we bring in the novelty in this particular work. Can we move forward, please? And these are the broad aspects of this model. It basically is the transportation of rerouting the food to alternative destinations. Cost and summarize the environmental and social. So here rerouting cost, because we also built the model to address particular hub or food grain the destination node. We try to model that by a hub and spoke model and try to incorporate an emergency hub which will satisfy the original destination when some of the intermediate nodes are disrupted. The food grains and then satisfy. So that was the rerouting part that was incorporated newly in this particular model. And environmental emissions, we have formulated the environmental emissions transport done by trucks as well as trains. In hub and spoke model, some amount of food has reached locations to a transship. It transports destination in trains. Environmental cost involved with this environmental emission captured from all the transport of roads as well as trains. Considering social congestion and also social human life due to emissions. Components were importantly considered to capture the social. Was built to optimize or arrive at the optimal ship, the optimal hub location, the optimal total ship. Understand objective function, all the different types of costs involved in the transporting food from origin to destination. That's the gist of the whole work, but you can go through the model which I've also included in the presentation in detail. And if you have any questions, you can always come back to me and work on the similar model. And also we have extended as objective model, because one can argue that why have you considered everything into a single objective, whereas a multi-objective in nature. Cost estimate all of them into one. Is always a question. I need to also model it as a multi-objective problem, and this paper is published in economics. The objective version is published in Transportation Research Part E. Of course, in that I have addressed some additional considering route conditions and other complexities also. If you're interested to approach me on similar works, always please feel free to approach me via email. So yeah, I would like to conclude here in the interest of just to summarize the different types of cases we have seen. Initially, we talked about the re-emit cases. Just to show you the different problems that may arise in practice and the broad data-driven modeling kind of scenario. And next, prescriptive models can be built and can be used to solve problems from agribusiness. The session will be useful to give you a broad understanding in the limited time available. So I'm sorry for extending the time above 9 o'clock and also cutting short because of the initial glitch that also happened. So yeah, I would like to conclude here, and if you have any questions, kindly I'm open to answer.
Any question you can ask if you have. I think no question, I think. Okay, sir.
Yeah. If anybody has any questions, they can say.
Okay.
ID.
Yeah.
Yeah.
Yeah, Jennifer, can you propose vote of thanks and we can conclude this today's session?
Yes, sir. So good evening, everyone. I, Jennifer, coordinator from Indian Institute of Plantation Management, feeling honored to give this vote of thanks on behalf of everyone for this most insightful session. I would like to thank Dr. Lokitaksha Maniraj Mayer, sir, from Indian Institute of Technology, Hyderabad, for sharing his knowledge on the topic of analytics for business model transformation for agribusiness organization, which was very informative and insightful. Sir, I wholeheartedly thank you for handling this session and making it a grand success. I would like to thank all the coordinators of Indian Institute of Plantation Management, Bengaluru, for coordinating this program. I would also like to thank all the participants for your encouragement and active participation, which was the key for the session success. So finally, on behalf of Indian Institute of Plantation Management, Bengaluru, I would like to thank all the participants, the resource person, and the coordinators. Thank you. With this, we'll wind up today's session. Thank you.
Okay, sir. Thank you.
Thank you.
Any doubt, they will contact you, sir. Anything, sir?
Thank you very much.
In feedback link, I'll be shared. Okay. Yeah, we'll end the meeting.